Hi everybody, my name is Benjamin Sarakach, a student of Victoria University, uh, under the Faculty of Institute, under the Institute of Education and Learning, Lifelong Learning. So today I'm here and I'm presenting to you my coursework that I was assigned to by my lecturer under the Introduction of Chemistry, and in this in this practical presentation, I'll be handling or talking about the environmental water quality assessment. So I'm going to be assessing the water in the community using the chemistry knowledge in this module that we are learning, whereby we will be looking at so many things, but amongst all we'll be testing for ions, mostly the composition of ammonium and composition of carbonate ions in the water that we use for our daily activities, drinking water, water from the lakes, we use for domestic use, cooking and other things. So in this case, I have some equipments here, that some equipments and materials, or rather the resources that are required of me to conduct this lesson successfully. Thumbs up to my lecturer, Mr. Mark Halley, who is facilitating, who is giving us this quick knowledge and facilitating us adequately to ensure we get the best that we need. So in this case, we are requested, or we are asked to have the following materials that I'm going to use. This one is beetroot, so I've cut it in two pieces. But in this beetroot, what we need mostly is the extract, and I'm going to extract this beetroot using our local resources or the available resources, which is the bottle. This is my drinking water bottle, and then I'm going to add some hot water, well boiled water. This is going to help to facilitate, or this is going to help as a catalyst. That water is going to speed up the color extraction from the beetroot, since it has what we call beta-cyanin pigments, and this beta-cyanin pigments is its main work is to change the color depending on the pH of the water that is provided or it is applied to. So in this case, we'll be looking at it in different ways, but let me first show you other materials I'll need to use. I have sodium bicarbonate, or you can call it baking soda. I have acetic acid or vinegar. I have the cups, different cups. I may introduce other cups in the future. Then I have the beetroot. I have the knife I've used for cutting. This is not blood members. This is just the pigment from the procedures I'm running. So I'll need a spoon. So each item I'm showing you here will be very important. Even the papers will be needed, but for now, yeah, this is why I prepared my stuff. And then let's move to the next step. I'm going to be handling question number 1, whereby in this question I'm required to test for the presence of common ions using simple qualitative tests. And in this test, I'm going to test for iron. And the iron I'm testing first is carbonate ions. And in this case, I'm going to use vinegar. If you are able to access to dilute hydrochloric acid, you can. Sorry about that. The dilute hydrochloric acid. Members are at work. That's why you see people are coming in, but don't worry. But for us, for me, I'm going to use acetic acid because it's locally available. I was able to purchase it from the supermarket. Then we have the procedures that I'm going to look at, like add a few drops of vinegar to the water sample, observing, and you do the observation and you write the conclusion. Then you have general acidification. This one also will be tested. Ammonium, carbonate ions. This one I mentioned earlier, and then the pH. So briefly in this assignment, I'll be talking about the pH. I'll be talking about the ammonium and the carbonate ions. Thank you for following, and I ask you to stay tuned as I start the procedures. One, I'm going to fetch water. The first sample of water, I have water from this distilled water whose pH is 7.2. So this water is here, safe for drinking. I have hot water. Where necessary, I will use it. I've already added it in this bottle to make sure that I extract the color of the beetroot. Then I have the normal and cold. So we shall be looking at one item at a go, and then we see what comes up. So I'm attempting the first part of my question, whereby I'm going to test for carbonate ions, and in these carbonate ions I'm going to use vinegar, and then I'm going to use water from different sources. I'm going to bring the water from the tap, and I'm going to use the water that I have here, distilled water. So the other water source. Yeah, like I told you earlier on, I'm from fetching water from the tap. Now I have water here, and this water is my normal drinking water, distilled drinking water. So I have two samples so far collected. So dear members, here I have two types of water. This is tap water, this is drinking water, purified drinking water. But the cups being the same, it may be a problem for one to differentiate. So what I did, I got a reserve cup, another alternative. So I'm changing this drinking water for this cup. Then they will be able not to forget. So my work begins. I'll start by adding some small amounts of water. This is drinking water in one of the glass or cups. I have a plastic cup. Then I have this water also. So I've marked this one tap water. So this is our tap. So I've marked this one as tap water. So I'm going to add tap water here also, almost to the same amount. So my procedures, and the procedure number 1 tells us to add few drops of vinegar to the sample. So this is my vinegar, and the drops I'm going to add. To avoid spillage, don't pour it around your body, and make sure you have a well ventilated area. So my vinegar is here. I'll start with the drinking water. I add few drops and make my observation. So drop 1, 2. So I only added 2 drops. what I'm seeing a very tiny bubbles, very small, and they are appearing at a minimal rate. Few amounts have shown up, very little. If you're not very keen, you cannot see anything. So my observation, I've seen some little bubbles, very small bubbles, very small. This is what we call fizzing or effervescence. Then this tap water also, I'm going to add very small. So immediately in this one, immediately the acetic acid dropped. Some moderate number of bubbles have shown. So also effervescence has happened. So in our observation, if you see the bubbles, meaning there are some. If you see the bubbles popping, or you observe what we call effervescence, indicating carbon dioxide is being released from the water, and this alternatively shows that there are carbonate ions in the water. So effervescence in simple terms, this is fizzing or bubbling. So when you say bubbling, meaning that water there is a composition of some carbonates in the water. For example, when I look at my water here, it has a composition. This one is, we are lucky, it has a composition of 20 mils, I think 20 milligrams per liter of bicarbonates. So fizzing or bubbling, this one proves that there are carbonate ions in the water. So in my explanation, I will say carbon ions react with acetic acid to produce a carbon dioxide gas, which appears as bubbles. So whenever I see a bubbles appearing, this one confirms the presence of carbon dioxide gas, and this one automatically tells us that this water has carbonate ions. So in my conclusion, that is it. Water will be there as what will be the product. We shall have carbon dioxide, we shall have water, so, and maybe a salt. That is my observation for the first assignment. See you in the second assignment, please. So members, don't always forget to clean yourself, clean your hands and your workplace after an experiment, and always clean the apparatus before moving on to the next activity. So I'm going to the second activity, and in this activity I'm going to be looking at the general acidity or acidification. So in this case, I'll be testing for general acidification. So this one mostly is possibly possible when you are using the possible resources, because here you will need a pH measuring tool or indicator tool to know the acidity. But still, we can use our sample Remember this sample here? This is what we call the pH indicator. So now that I don't have the litmus paper to dip into the water, I'm going to use our tap water and the drinking water to run the remaining experiments. So let's see what I have here. Let me add something here and see if we have, yeah. So you see, I've acquired this color. Please don't test the lab chemicals, however appetizing it looks. Don't use it. Is dangerous and unhealthy, and it can cause more problems. So when you look at this, you see that color there. I have a pink color inside my cup, and I'm going to use this one to identify the different pH in my water, both the tap water. If you remember this is tap water. This cup was not tap water. Yeah, it's clear. So this one I'm going to add my drinking water, the purified water. So I'm going to add some drops of this sample, and this sample is from beetroot. It is purple in color. So I'm going to observe the changes in color over time in this experiment. So the change in color determines what I have, what the pH I have. For example, in this one, according to my assignment here, if you use I must use vinegar to acidify the samples. So I'm going to add vinegar in some samples. Then I'm going to use these for my experiments. I'm going to use this pigment. So here we go. If I add to this water, this is drinking water, it is clear. But if I add, I think you'll observe something like that. I'm trying to attain the concentration. Don't worry, I have enough. I have something color like soda color like that. Then also this one. So when I look at this, when I look in these cups, the tap water and this purified water, let me give it time and see. So my solution, I waited for about 2 minutes, and in these 2 minutes, the solution in both cups has remained the same. The color has not changed. So I'm going to add the water. Sorry, I'm going to add acetic acid. Remember, acetic acid is the vinegar. So I'm going to add 1 drop in the drinking water. And also 1 drop in the tap water. So dear members, at the beginning of the experiment, all the water retained the same color of purple. This indicates since I'm not using the accurate measure, this water is at a neutral pH, but when I added acids or acetic acid, so remember this is the original sample, if you can see very well. So this sample is a beetroot extract before being added to the water. So when I put in the two, it maintained the color. So when I added acid, when I added acetic acid, this dilute acid, it's a weak acid, to the drinking water, this is what I observed. After some time, my tissue turned pink. So this pink or red indicates acidity. So meaning that the water level of the pH level of the drinking and tap water is almost the same. This is due to the reason that because of the treatment, the hardness was broken down, reducing the alkalinity, hence nearly balancing the pH. So, meaning that when more acid is added to the water, it causes this litmus, not litmus, but the indicator. It causes the pigment in the beetroot to change the color. And there was no effect. Upon addition at different intervals, I observed that colors changed to pink. So, in this case, I'm adding the, our instruction only asks us to add the vinegar. So added the vinegar, and that's what I came up with. Therefore, in my conclusion, this water is neutral water, because when you look at the pH of the drinking water I have is 7.2, making it slightly alkaline. But with this one, I cannot determine whether it is base, its pH is base, or it is acidic. Meaning that it is between neutral and alkaline. Therefore, there is availability or possible chances of carbonates or different carbonates being available or present in both types of water, hence creating some hardness. Okay, one more before we proceed to the next assignment. These are the key indicators when you're using the beetroot. If the water turns red or pink, this confirms the availability or the acidity pH level. If the water contains or retains its original color, purple, this shows that the water is neutral. It may be neutral or slightly acidic or slightly basic. But if it shows yellow or green color, this one will show it's a base or it's an alkaline water solution. And in this, if it is an alkaline water solution, it can't be good for use. This one will be it will be under the permanent hardness, or it will be hard water. But for this case, yeah, I think it's temporary hardness, and this water is safe and good for use in the community, both drinking and other activities. If it was at an alkaline pH, it could be dangerous for the use due to the composition of the salts, which can cause the salts and the carbonates that can cause the body to be pale, you have a dry skin, you bathe and then you have a netted skin, whereby that because of that action from the salts or the carbonate ions. I love you guys. I'm moving to the next assignment. So in the next assignment, I'll be talking about, I'll be testing for ammonium ions using sodium bicarbonate. This one here. So why are we doing this? What is the aim? The aim is to detect the presence of ammonium ions in a water sample using sodium bicarbonate. So we are going to use our two water samples. Remember, we have the tap water and we have that water also, the drinking water. So what we shall need mostly is the sodium bicarbonate, acetic acid. We have it here. Small container. I have this one. Always remember to clean this after use if you don't have enough. We have heat source. I'm going to use the hot or the already boiled water. I'm going to use the hot or the already boiled water. So this water is boiled. I think you can see. So we shall need this warm water. Then we'll need this spoon for adding. Oh, ongeza, eh? Yeah. For adding the samples to get the balanced composition. So let's begin. Here in my procedures, they tell me to put some equal amounts of water. Some, not too much, about 10 mils, 5 mils. Yeah, don't too much, not to fill it. Just, yeah, this is enough. Then I'm going to add this. So, I have tap water, I have drinking water. This one, tap water, is always marked. Don't forget. So, in this case, I'm going to have what we call the second step is add small amount of baking soda to the sample. So I'm going to have two cups with hot water at the same temperatures and at the same levels. So I have hot water here. Hope you are able to see this. And hot water here. So the experiment tells me using my spoon. So members, be careful when you're handling this. Don't have it sprinkled everywhere. So I've opened it wide so that I can scoop. I add some amount. See? This is our drinking water. No, this is the tap water. So I'll add this here. I think you all can see this. Then also same, please as you add, you observe. Me, I've observed bubbles when I added this. Some 3, 4, 5 bubbles popped here. Then also here, have the same amount. Also I've seen bubbles popping. After this, don't forget to cover your resources, keep them away. Then there, second, third step, they said warm the mixture gently, do not boil. So using this my hot water, using this warm water, I'm going to put this. Then they said carefully smell. As you stir, do you see that? Okay. So guys, you will miss this. You cannot smell. I felt a pungent smell, a pungent odor. This proves the availability of ammonia gas in these mixtures. Wait a minute. Wow, but it comes out, you know, at a slow rate, not too fast, but you can feel it, that sharp odor. Okay, so this proves the ammonia ions. These bubbles you see fizzing, this is a proof of the ammonia gas. And ammonia gas, there is some of its properties. It has a pungent smell, a pungent odor, sharp odor, very very sharp. And in this proves that we have ammonium ions in this drinking water. Oh my God, have ammonium ion. Okay. So as I draw my conclusion, I will say that when heated, sodium bicarbonate creates a mildy alkaline. It creates a salt. So it creates a mildy alkaline. I feel my throat is scratching. They told me not to inhale a lot, so I stopped there. So sodium bicarbonate creates a mildy alkaline called ammonia. So if ammonia ions are present, they react to produce ammonia gas. That's why we have that pungent smell. So dear members, that is my conclusion. Please, if you have adverse knowledge and advice or corrections, come down in the comment section. Another one. So members, after realizing that the pH of my water is almost the same, I decided to use one sample. So this time I'm only going to use the tap water. We have to minimize the usage of resources and utilize them properly. So in this case, I'm going to be testing for carbonate ions using sodium bicarbonate, and I'll need the following. I'll need the acetic acid. I'll need a spoon, which is already here. Then I will need I'll need the containers. So in these containers, they are according to my procedures. First, I need to have chalk or sodium bicarbonate here in my cups. So I'll get this. Please avoid to use too much to prevent spillage. Remember, this one is highly reactive. So I've added my powder. please always remember to seal after use. So after adding my powder, I am asked to add vinegar. To add vinegar, why am I using 2 cups? I think 1 cup would be enough, yeah. So I'll add vinegar here, as usual. And this vinegar will be introduced in the cup containing sodium bicarbonate or the baking soda. So what are we observing here? We are observing the fizzing. How many people enjoy Pepsi? Enjoy Coca-Cola? Here is the deal. So we are talking about the fizzing. In my first one, wow, I love the sound. I know you cannot hear it because you're very far, but let's observe together. This one I'm adding when you're also watching. So you see these bubbles? In this cup, it was like this. In this cup, there is only sodium bicarbonate inside. So this I'm going to add. Could you please watch and observe what I'm doing? So when I add this acetic acid, this is the reaction. Wow. See those bubbles? You see the fizzing? You hear that sound? Wow. So that was my voice, but hope you saw what I was trying to indicate. So this fizzing, if you observe this, we come down to note down our observation. And in my observations, they tell me that effervescence occurred, and this indicates the presence of carbonate ions. And then my conclusion, carbonate ions are present. And lastly, my explanation says, when carbonate ions react with acetic acid, it will form or produce carbon dioxide. Hello. So the gas you're seeing, that fizzing, those bubbles you're seeing, that is carbon dioxide, which proves the presence of carbonic ions. Thank you so much for listening. We meet in the next assignment, where we will be having much deeper discussions about the beetroot. Remember, I have one left. This is not for eating. It is for my study purpose. Alright, members, I wish you a blessed time, nice day, nice evening. At any time you watch this video, I remain Benjamin Sabakach, a grade 3 teacher in the Faculty of Education and Lifelong Learning at Victoria University, living in Dubai, working in Dubai. Happy to join. I'm proud to be a member, a student of Victoria University. Viva, viva, Mr. Dr. Muganga, Professor Benita, and all our support staff, technical staff, and whoever is doing his or her best to ensure our success and excellence. I wish you a nice time. Love you.